In this question, we'll be using the conservation of momentum and restitution equations. Two particles colliding and then moving off, and we need to find their velocities after their impact. So to start with, we'll use conservation of momentum. I've already set up the diagram as to what's happening. Careful to note that B is moving towards A. So momentum of A is 3 times 2, velocity times mass, or mass times velocity, plus minus 4 times a half. That takes into account that B is moving towards A. We'll take left to right as being the positive direction, equal to VA times 2 plus VB times a half. So rearranging, we got 6 minus 2 is equal to 2 VA plus a half VB. And eventually we get to 4 is equal to 2 VA plus a half VB. A suggestion here would be, it's likely we're going to use this equation along with the second one simultaneously. So if we double up the equations, we get 8 is equal to 4 VA plus VB. This is our first equation using conservation momentum. The only other equation we have is utilizing restitution, and we know that the restitution, coefficient of restitution is 2/7, and restitution is equal to separation speed over approach speed. Well, the separation speed is VB minus VA, and if we examine our diagram, we can see the approach speed is going to be 7. In this case, A is moving towards B and B is moving towards A, and their overall speed that they're colliding with would be 7. So we can see immediately that the denominators are both 7, so they can be cancelled, leaving us with 2 is equal to VB minus VA. Two equations, two unknowns. Now with these two equations, you can either do one of two things. You can rearrange one of them to use as a substitution, which I'm going to do. So I'm going to take this equation and I'm going to say that VA is equal to VB minus 2. I'm now going to substitute this into here. So I'm going to get 8 is equal to 4 lots of VB minus 2 plus VB. So 8 is equal to 4 VB minus 8 plus VB. And we can see that 16 is equal to 5 VB. So 16 over 5 is equal to VB. This gives a value of VB as being 3.2 meters per second. Once we have VB, we know that VA is equal to VB minus 2. So VA is equal to 3.2, take away 2, so VA is equal to 1.2 meters per second.